Hello my friends, this is a stellar day at Mud Fossil University. Fermi Labs has finally said uncle. Now, I've been telling them and everybody else, all 100%, that I have seen photons and I have seen the muons and the whole 9 yards, electron showers. So they have, what is a photon? Now, here's what they say the photon is. All right, so here's their little article here. What is a photon? And the photon is from a wave to a particle to a boson. Exactly what I've been showing, only they got it wrong. It's from a particle to a wave to a boson. Now let me show you. Okay, so anyone who is a true scientist would say, Roger, 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 can you prove what you're saying? And I say, Roger that, I can. What am I talking about when I say a particle? Well, this literally is the photon. And it is a particle, there's no question about it. And we can literally separate the black from the white particles, which is the boson is the black, the white is the electron and the electron shower. And they call them neutrinos, muons, they got some million different names. All it is that particle is way back here. It's coming this way. It has a magnetic field around it, just like if you had two bar magnets and they were together, they'd have a magnetic field around them. This is just the way it works. Now, every other particle that exists has a magnetic field around it as well. It has electrons coating its surface, which I will explain to you a little later. But every gas molecule that's in the air has an electron attached to it, absolutely no question whatsoever. So as this pushes through, it creates a wave just like a jet fighter does through the atmosphere. Now, what we did was we took that wave and accelerated it, as you can see right here. So that was the wave. Now, the particle was back here before. Now the particle has actually come forward of the wave because we put it through a venturi, which is nothing more than an accelerator. And at that point, we have atomic interactions. I mean, it's subatomic because this started with light. So don't tell me that it's not the smallest particles there are, because it's light. It's light from a red laser. Light is light. Now, when it hit here, it broke its light into muons and bosons, or muons, electron showers, whatever you want to call them. Because the black particles that started are now all around the edge, and I'll show you that. And then they reattach down here. We can get free energy right there. This is an absolute gigantic explosion of energetic particles. Now this is that particle beam coming in here, and it's a beam of particles, and you saw them, they look just about like this, and the green and the blue and the red, they'll all look the same. Well, the blue is a little hard to see, it's just kind of a little too fast, but the green and the red, I'll show you, absolutely flawless box of particles. Now here, what do we see? The black ones no longer are attached to the white. The white are all by themselves, 100% by themselves. That is what's called, you can call it tau, you can call it muons, you can call it bosons, anything you want to call them. But that is raw electron energy that the black particles, see over here the black particles? They want to be attached to here, just like you saw them before. They can't get through here. For some reason, and I can't explain this yet. We need to look at this deeper, right? And then nobody will correspond. So it's very hard for me to get any further. But I know in this area we have raw energy, and it's obviously enhanced its energetic value exponentially. And all we did was had a venturi here, and I'll show you the venturi. It forces the light to go through and crush its fields. And then these are the muons, and I believe this is dark matter. Nobody's ever seen it before. Nobody realized it was attached to electrons. And you can see it follows them right out until they finally get back together. You see it? And they finally end up getting back together and turning back into just regular, normal, background, which is undisturbed electrons. Electrons and photons are moving. Electrons don't necessarily move. They can attach to things as static, and they are on everything. So there's electrons, virtually everything is 100% coated with electrons. Everything. Because the electron, it wants to get away from each other. So the black particles get pushed to the center. I'm going to show you on the whiteboard right now. Anyway, CERN had it, Fermi had it semi-close. It's a particle creating a wave, creating the bosons. And that's where we get our energy. And we could just put a solar panel right there and harvest it. Like in a week we could have free energy. All right, this is what we were talking about a minute ago with the particle creating a wave in front of it, because it's a magnetic region that if it pushes all the other magnetic particles, which everything is a magnetic particle, everything has a negative potential to it. So if this negative potential coming through hits that negative potential, it has to get out of the way. It creates a wave, and as it does that, it makes this spin, because it's push to shove, push to shove, push to shove, that type of thing, and that creates the wobble and the spin they talk about. It's all very simple. Now, the laser shoots the particle approaches the venturi, the magnetic field is now forced down. It's just crushed. And at that point, all the black particles, which are the gravity, and these are the muons, they're the attractors, they just get out of the way, they just move. And I'm going to call on the bosons, because that's what they're talking about. So we got particle, wave, boson. Exactly what they want. That's what we want to get our energy from. Because very, very shortly after, these black particles move back in. I believe there is excessive dark matter everywhere, and all it's doing is waiting for some white ones to come along to snap against. And we absolutely remove the white ones from the black ones, so they really, really slam it back in here. If we could just put a harvester right in there, a solar panel right there, and run it down to whatever, attach it to the wheels of your car. I don't care what you did. This is a tiny little device, and these are portable, controllable. This is nuclear atomic fission, right? What we do now with the old style nuclear power plants, well, they were fission plants. They were breaking particles apart, but they were starting with the biggest chunks you could ever get. Plutonium, uranium, all that stuff. So when they broke them, if it got running away, you were in trouble. We're starting with light. We're only using light. So we're splitting only the particles of light. There is no possibility whatsoever of a runaway. There is no possibility that can it be harmful to anything. If it's boxed in a box and you're sucking that particles out of it, you're getting free energy. Because this is increased at least 200 times, they say, if you can do this, which we did. So that's that. Now, and this is all it is light coming through here. The wave, it's also spinning at the same time it's going through. So, and that creates a lot of these patterns here, because sometimes it spins this way, sometimes it spins that way coming through. And I have all of this in extreme detail. So we're showing exactly what Fermilab wants to see. Now, they're starting to talk about chemistry finally, because this hydrogen is not one giant proton and one electron. It is approximately 1,840 or 41 electrons, and then one more that wants to try to get in, but it says, no, we have enough. Stay out. This is a dipole, and one more dipole once again, and that's all that exists is dipoles. These are aggressive killers because they're electrons and they want to incorporate into something, and if there's enough of them hit you at once, you're dead. Photons, a different story. They're semi-stable because they're attached. They're going to bang into you and bounce off. If a ton of them hit you with a laser beam, yeah, it's a little different. You're going to get burnt. But normally, they're just going to bounce off you. Every atom, every molecule, everything there is coated with the electron portion of the dipole, the explosive portion, because it wants to get away. It forces the dark matter to the center. Now, there's Heisenberg's uncertainty principle talks about whether two things can occupy the same space at the same time. And this may be possible, that the dark matter is being forced in there and it can exist in the same realm with the other dark matter. I don't think so, but it's something to explore. because I've always just thought that was just insanity. How can something be in the same place at the same time if something else is there? It's just ridiculous. But dark matter is doing some ridiculous stuff, very ridiculous, and a lot of it I can't account for. All right, but anyway, what I'm talking about now is a whole change. Protons are like 1839 electrons. Neutrons are 1840. Everything is push to shove. There is nothing that exists that doesn't have both. All right, the only thing that exists, we did it here. That's the only time it exists that it doesn't have both. And they're looking for this to have it as an accidental occurrence. And CERN has, was it CERN? Yeah, I guess it was CERN. The Large Hadron Collider, yeah. They have seen these too. And I can show you the article about it. They're going to try to use their collider as a photon collider. All they got to do is go out and buy some little tiny cheap lasers. They're like $50, and you can do exactly what we did. And all you need to see this is a cell phone. He's, oh, Roger, you can't see photons with a cell phone. Like hell you can't. You can see them because at that point they are energetic particles. They're not just photons sitting around darkness. They have energized. Okay, I'm doing about 6 things and I might have got a little confused here, but I'm just going to give you a quick lay of the land. That is light, and that is the wave that is created by the particle. That's the particle. We accelerated it through a laser, through a venturi, and created muons that walked away, little black balls, and electron showers, precisely what CERN and all the rest of them want to see, Fermilab. These are the Higgs field. They are created right here. And the reason they're created is this white spray of electrons crashes into the gases that are in the air and makes them spin. And creates these fields because they smash into them at these extremely high rates of speed, which is an enormous interaction. Those are Higgs fields. Now, we had this, which is a reverse spinning particle that created something that was just totally unknown. That is blue. Remember I talked about blue being, well, maybe I did it or I will. Blue, hold on. All right, sorry about that. A lot of things going on. Now, this is the blue. I remember I told you there's a little hard to see, but you can see that it's obviously going fast here, and it's obviously slowing down here, to my way of thinking. Now, we can see light can speed up, it can slow down. There's just no question about it. And it can separate, as I showed before. Now, this is actually, all it is in the experiment, a red pulse laser. And it is literally right on the venturi, literally on it. And when it comes out of here, it has nowhere to go except through it, or the black balls go around. So I'm showing it's separated. It's not really that separated. Now, this is what happens, though, at the venturi. And I'm showing 2 round cylinders, because that's how it first started out. And they just crush the fields. And then you get that spray right there. And that spray is 100% white in the center of 100% electrons, 200 times at least increased. WZ bosons is probably what they are. So you have the photon, you have the crushed fields, then it separates the positives and the negatives, and when it comes out the other side, you have a 200 time increase. So I hope that made sense. All right, these are the red photons, and again, it's 2 electrons back to back, and they explode at the venturi. Now, the green is exactly the same, only it's a lot more energetic. All right, you can see it's pretty energetic, and that's the particle, but same particle. So all it is a faster spin, and all it means, I think I showed you. Hold on. All the color is the length of the wave. And I say wave because it's a spinning particle which looks like a wave. Here it's a faster wave. Here it's a very fast wave. This is blue, this is green, this is red. They call it red shifting. As it slows down, it shifts to the red range. And there's so much stuff in space, everything is slowing down. So think about that. Now, let me show you something else. This is what CERN and Fermilab and all want to see. Exactly what I showed them. Muon, the black particle, the green or the red or the blue particle attached to it. When they crash, and when they're just sitting around, they call them neutrinos. When they smash into something as photons of light or particles, you get muons and you get electron showers. It's like exactly what I showed you, and they call them bosons now. They call them all kinds of things, but that's what it is. Now, and here's what they look like when they're actually, when we're actually looking at the actual particle. That's the actual particle, and this is the enhanced particle. But they only show up in this box configuration just when they are in the process of transitioning from a high speed and slamming into something. And that's what they also know. They call them electron showers. So I'm not revealing anything exceptional here. It's just that we happen to see this and find out and realize that, well, you know, I have a background in this, so I understand what we're looking at. I mean, I've been doing this 50 years, and I had the electron flood theory 50 years ago, which says nothing but electrons exist, which are dipoles. Everything is made of them, only in bigger and bigger and bigger balls. So in other words, you don't have protons and neutrons making up the core and then a couple of little tiny particles floating around. No. Instead of this being the core, this is the core. And then you have all these little particles that are everywhere. They're electrons. You walk through the air and you collect on you. You go in a dry environment because they don't have water to attach to. You got more water, so they come to you. They just sort of stick to you. Then when you get close to a water pipe or ground or something that will accept them easier than you, snap, you feel that little crack. That's because these babies want to attach to something. And if they can get to ground, they're attached. But when they're floating around in the air as free molecules and there is no water really for them to attach to, then they become very excited. And I'm a little concerned about some other things that are going on now about manipulating the airwaves with 5G, which is in the microwave radiation, and it splits water molecules, which I'm a little concerned about. But you know, to be honest, you have to be honest, and you have to be open. You have to discuss every possibility that is destroying our planet. And there's no question the combustion of solid matter into gaseous matter just creates more and more envelope in our atmosphere, creating more and more scrub as we scrub through all the other particles in space, because this is light. That's the exact same stuff that's coming from the sun. John Glenn saw it in 1962 when he circled the Earth 3 times. He said every time he came up into the sunrise, he could see all these particles, thousands and millions of them everywhere. And he described them, and he said they were a little colored, they're 1/16 of an inch approximately. So he was seeing the same things that we're seeing when we energized them. Because that's the ionosphere. That's where they're being ionosphere is ions. It's energized particles. We're seeing energized particles ourselves when they concuss. That's what he was seeing. So anyway, it's a very exciting time in physics. Extremely exciting, especially for me after 50 years of really pushing this and finally seeing it. Because they say a couple of days ago, they said, yeah, Einstein was wrong, and now we have to move forward. I'm seeing this, all of them now. They have to. It's very hard for them to say that in an open forum, because right away they will be attacked. But trust me, no question whatsoever about that. And they have to be pretty damn strong to stand up and speak up now. But now is the time, because they're going to be shown to be correct. So stand up for yourself. Okay, like I said, they are starting to come around. This is just recently, and this is dark matter findings suggest Einstein's theory to relativity may be wrong, and this is BBC News, and I'm just going to play it from here and let this young fellow start talking about what they have.
Structures in this map are smoother than we expect them to be, which is what the results seem to hint at. It means that Einstein's theory is wrong. So you might think that that's a bad thing, that maybe, oh no, physics is broken, but for physicists it's extremely exciting because it means that we can find out something new about the way the universe really is.
Building on the work of Einstein, Carlos Frenk was among a group of scientists that developed the current model of cosmology.
Hearing now that there may be something not quite right with the theory, well, it's very disconcerting, it's very alarming, and in a way frightening to see that maybe my whole life's work might crumble in front of me, but at the same time, it is immensely exciting.
Astronomers believe that we are at the start of a new revolution in cosmology that will give us a fuller understanding of how the universe began and
And he's exactly right. Now, he's talking about his whole life crumbling in front of him. Did this 50 years ago. This was my whole life, and they crumbled it in front of me. And I never gave up. You see how dog-eared this is? I just want to make the point. This was my treatise on the particle nature of the nucleus, that it's not protons and neutrons, it was electrons. It had to be dipole, let's put it that way. I really couldn't come down. I did a lot of work on this, trust me, for years and years and years and years and years and years. And I was denied all that time, so it's good. You know, it's going to be a hard thing for all of them. I understand it, very, very difficult to step up. But that guy, God bless him, because he's saying the truth. And if they can't handle the truth, you better get out of the kitchen. All right, I'm going to leave it at this. This is not rocket science here. This is absolutely high school stuff. A tiny little laser accelerating through a venturi creates these showers. You can't stop it, and it's just free. No input whatsoever other than the venturi. When it comes out of here, it's highly increased in value. It's just like putting something into a piston, and the piston explodes when you throw a spark in. You don't even need a spark. It just happens. Now, we can harvest this energy, and maybe we can even get out of this global warming situation, because these are portable, these are tiny, these are extremely, I'm sure you can get a ton of energy out of it, and they are not polluting, and they will not explode. You cannot explode them. The harder you hit the venturi, the more electrons are going to be flushed through here. The more electrons, the more energy. Simple as that. Less pulses, less energy. More pulses, more energy. It's just like having a throttle in your car. And he made you be able to just throw one of these little boxes in your car and never stop driving your whole life. Never fill up, nothing. I know it's scary for everybody, but it's, and you know, you got to look at it like opportunity. Don't look at it like, oh boy, this is going to break everything. No, it's not going to break everything. If we could get enough energy to fix the world, how would that be? That'd be pretty damn nice. All right, somebody get a hold of me, Roger@mudfossils.com. And, you know, I'd like to see this thing resolved. Or at least I'd like to be part of the conversation, because I'm telling you right now, electron flood theory, which is my electron flood theory right there. That's it. That's it. That covers everything. And that's the only way we're going to get out of this problem we're having with burning fossil fuels. I'm telling you right now, we are in big trouble.